AI shouldn't cost more just because you speak a different language, but because language models tokenize languages differently, equivalent prompts can have very different costs. And that's why I built this MCP tool called SlashToken, and it's a multilingual gateway that checks whether a prompt can be safely converted into a more token-efficient form before it even reaches the model. And it only uses this optimized route when the savings are worthwhile and the original intent and constraints and protected details are all preserved in your original prompt. I know that sounded a little confusing, but that's why I'm making this demo video. So this is my local UI that is connected to Codex right now, but we have to go through a few steps before we can actually use Codex from here. First, we have to fill in what folder we want Codex to work in, as usual, as you do in the regular Codex or Claude Code UI. So I have an empty folder right here called MCP tool or MCP local test. So I'm going to enter it in here. And you get to choose your model. I'm going to use 5.6 Sol because that's what I always use. And there's two modes that you can work in this. You can work in coding, or you can just have a chatbot answer for use cases like HR or writing an essay or etc. For this demo, I'm just going to keep it at coding. I'm going to be optimizing language and optimizing output. You'll see what optimizing output looks like in the end. So now we have to put in a prompt to optimize, and I have a very long Japanese prompt. To optimize this, all I have to do is press analyze, and it will start analyzing the prompt and seeing if it is able to preserve the original intent while also reducing a significant amount of tokens. Okay, so now it's finished, and you can see my original route this is the prompt that I just entered above. It took 4,271 tokens, while my optimized prompt in English that's cut down uses 2,440 tokens. And obviously this is a lot to read, so I'm not going to make you read it, but I can promise you that all the details, all the protected values, and all the intent is still preserved. So now the next step is, if I was a developer, I could review my original prompt and review the optimized prompt and see if everything is there that I need. Is anything missing? If there's nothing missing, I can approve this candidate, and now it will submit this prompt into Codex. And you can see down here its progress. As this is going to run, you can see a live feed of the amount of tokens that are actively being spent. Okay, so it seems like it's finished. We ended off with a total of 2 million tokens, including the input and the output and reasoning. So let's go and see. Okay, this is the final product of what I found in the MCP local test folder. As you can see, every button works. It's a good skeleton for an e-commerce app if you actually want to make one. I know top AI providers like Anthropic or OpenAI are getting better at multilingual tokenization by the day, but I wanted to do my own research and see how I could do this myself, and it taught me a lot. I think this project was a very good use of my time. I also have a landing page that shows a little deeper on how this works. It breaks down the routing logic, and it explains a few safeguards that I've implemented, and it shows real examples that I used to test it originally when I was building it. I also have documentation if you'd like to try and install it yourself. It works on Windows and Mac, but only for Codex. You can't use it in Claude or Hermes or anything else. If you want to contact me, I'll attach my LinkedIn in the description. Other than that, thanks for watching. See ya.